Section 13.2 is on angles in the unit circle. An angle in the coordinate plane is in standard position when its vertex is at the origin and one ray is on the positive x-axis. The ray on the positive x-axis is called the initial side and the other ray is called the terminal side. Here's a diagram from your textbook. As you can see, the positive x-axis here is the initial side. This ray going out into the third quadrant is the terminal side, and we indicate the angle by this counterclockwise arrow that starts at the positive axis and goes around to the terminal side. Oops. The measure of an angle is positive when the rotation is counterclockwise, and the measure of an angle is negative when the rotation is clockwise. And as you can see, this blue angle here, that's a positive 120 degree angle, and the red angle here going clockwise is a negative 120 degree angle. Let's take a look at a couple examples. This says, what is the measure of each angle shown? So here we have an angle that starts at the positive x-axis, goes up to the y-axis, back down to the x-axis, and actually goes halfway through the third quadrant. And the way that I know that is this point right here is the point -2, -2. So that's going to be halfway in between. So the measure of this angle is going to be 90 degrees in the first quadrant, 90 degrees in the second quadrant, and then half of 90, or 45 in the third quadrant. So this is a 225 degree angle, a positive 225 degree angle. This example here also starts on the positive x-axis but goes in a clockwise direction. 90 degrees plus 90 degrees plus 90 degrees. So actually a negative 90 because of the direction I'm moving, plus another negative 90, plus another negative 90 tells me that this is a negative 270 degree angle. Here's a couple more examples. Let's do it the other way around now. We need to sketch a 100 degree angle and a negative 215 degree angle in standard position. So because a 100 degree angle is going to be 90 plus 10, plus 10, I will start at the positive x-axis and go 90 degrees counterclockwise, and then I want to go an additional 10. Now this doesn't have to be super exact, but just so we kind of get the idea. So that there is a 100 degree angle. A negative 215 degree angle, well, let's see, so I know I'm going to be going clockwise, so 215 is 180 plus 35. So I want to start here at the positive x-axis, go 90 plus another 90 for 180, and then I want to go 35, which is just probably a little shy of half. Draw that angle, put some arrows there, and that is a negative 215 degree angle. Two angles in standard position are said to be coterminal if they have the same terminal side. So in the diagram below, the 135 degree angle and the negative 225 degree angles are coterminal, because here for 135 we start at the positive x-axis and go counterclockwise and stop 135 degrees over. For the negative 225 we also start at the positive x-axis, but we move clockwise 90, 180, and then another 45 to get to negative 225. So these two angles are said to be coterminal because they both terminate at the same spot. This example says find the measure of an angle between 0 degrees and 360 degrees that is coterminal with a 385 degree angle. You can do this simply algebraically. Okay, so 385 minus 360 gives me 25 degrees. Okay, but let's see what that looks like when we were drawing it. So a 385 degree angle is going to start here, and it's going to go around 90, 180, 270, 360, plus another 25 to get to 385 degrees. So an angle between 0 and 360 that's coterminal with 385 would be a 25 degree angle, something like that. Now the unit circle is a circle that is centered at the origin that has a radius of 1. Here's a diagram from your textbook. So here I have a circle that has a radius of 1 unit. Its center is the origin. A right triangle that has its vertex at the origin and one leg on the x-axis has a hypotenuse of 1 unit. We'll take a look at a picture of this in just a minute. The coordinates on the terminal side of the central angle correspond to the cosine, which is x, and the sine of that central angle. So actually, maybe I could draw one here. So if I were to draw a triangle that has its vertex at the origin, okay, and one leg is on the positive x-axis, so that would be this leg right here, okay? So what they're saying is that the coordinates of this point here, the x-coordinate would be the cosine of this angle, and the y-coordinate would be the sine of that angle. Here's a diagram from your textbook that shows a 30-degree angle. So what they're basically doing is creating a triangle, okay, by dropping that line there, and then looking at the positive x-axis. This is my 30-degree angle, okay, and if you recall, this is going to be, if this is a unit circle, this is going to be the opposite over the hypotenuse and the adjacent over the hypotenuse. So to find the exact cosine and sine values of an angle, we want to draw the angle in the unit circle, complete the triangle in reference to the x-axis, so drop a perpendicular line either down to or up to the x-axis, and use what you know about special right triangles to find the lengths of the legs. Then we want to transfer these values to the x and y axes. Let's take a look at a couple examples here. Find the exact values of cosine and sine for each angle. And the first one we're looking at is a 180-degree angle. Well, that's going to be pretty straightforward. A 180-degree angle goes up to 90 and down to 180 and stops right there. So that angle would basically be this part of the y-axis. So it ends on the unit circle at this point right here. And since this is a unit circle, that is the point -1, 0. So for this angle, so for a 180-degree angle, the cosine of 180 is going to be that x-coordinate, which is -1, and the sine of 180 is going to be the y-coordinate, which is 0. So for a 60-degree angle, 60-degree angle looks something like this. So I'm going to be looking for the coordinates of that point right there. This is 60 degrees, and when I drop this line right here and create the right triangle, this is going to be my long leg. So that means this vertical distance here is going to correspond to my y, and the long leg is going to be square root of 3 over 2. The short leg here is going to be opposite the 30-degree angle, so its length is 1/2. So the coordinates of that point where this angle hits the unit circle is 1/2, square root of 3 over 2. So the cosine of that 60-degree angle is going to be 1/2, and the sine of that 60-degree angle is going to be the y-coordinate, which is the square root of 3 over 2. And our last example here is a -30-degree angle. So remember, now we're going to be going the opposite direction. We're going to be going clockwise. So a 30-degree angle would look something like that. Hit the unit circle out there. There's my 30 degrees. And when I draw this perpendicular line to the x-axis, I've created this short leg, which is my vertical distance, and that's going to be 1/2. And then my long leg here opposite the 60-degree angle is going to be square root of 3 over 2. However, let's take a look at this. So my x, since I'm in the fourth quadrant here, my x is going to be positive, and my y is going to be a negative value. So the coordinates at that point are square root of 3 over 2, -1/2. So the cosine of a -30-degree angle is square root of 3 over 2. Oops. And the sine of a -30-degree angle is going to be -1/2. So in this section, we took a look at angles in the unit circle, how to draw an angle centered at the origin with its initial and terminal sides, how to tell what the measure of that angle is, and then how to find the sine and cosine of an angle when it's drawn within the unit circle.